Hello, everyone. Welcome to our panel live here in San Francisco, California. We are at Oracle are very proud to sponsor the Meeting of the Minds conference, and it's our second one. We were at the Toronto-based conference last year. Yes, I've been a transportation aficionado for quite some time now. The Southeastern Pennsylvania Transportation Authority. I was a CIO, and we were a surplus industry for our years there, and we were able to return money to the budget. So I know transportation can be, a surplus agency. We at Oracle have a way of mapping our sales into 25 different industries. And transportation is our sixth largest. We further map that down into aviation and maritime and transit and roadways. And we are very successful in all of those different verticals. Today we'll be concentrating on mostly the roadway segment and inner-city parking. And here, I do want to say that I've been involved with Atlanta. They use our software, and Georgia DOT. I've been involved, obviously, with Philadelphia. But here in San Francisco, we're very involved with the BART system and the San Francisco MTA, Metropolitan Transportation Authority. And our first speaker will be Jamie Ballesteros of the SFMTA, and he'll be talking about an award-winning smart parking system called SF Park. Jamie?
Thank you, Ralph. Yes, I am working with a fairly well-known project called SF Park, and you can find us on the web. I believe either sfpark.gov or sfpark.org will work. We were supposed to have bought both of those, so we'll see if we did that. But make sure that the reason why I'm mentioning that is that there's a great deal of documentation on what we did. There are standards that we publish everything open. The question earlier was how do we do this, not just in the city, but to go to surrounding communities and even nationwide. We tried to make everything we did documented in PDFs you can find on the web. All the rate change process we did is there. We have open standards for all our data interconnects, so please make use of that website. What was our project supposed to do? Well, in San Francisco, we have what we call multimodal transportation, where we deal with pedestrians, bicycle traffic, car traffic, taxis, buses, and then rail. Quite a unique challenge. We realized that one of the biggest problems we had was congestion, and that probably about 1/3 congestion within the city itself was caused by most of the time individuals in a privately owned car circling and looking for parking spaces. And through people who were on this project before me, they began to put together, if we take a new approach to parking, not only can we do a better job of parking, but we had theorized that we could reduce the congestion, reduce greenhouse emissions, and make it a better experience for the people who would want to park. And the different approach to parking is what's called demand-based. And the theory was that where there are the most demand, we would incrementally raise prices, not by the minute, about every 6 weeks. And slowly over time, we saw that we were able to push traffic out to the less used spaces and even out demand. To do that, we used the Internet of Things and big data, what everyone's talking about. In terms of our Internet of Things, we put sensors to tell you, is there a car in the space or is there not? And then we put smart meters that were able to not only accept typical coins as the older meters did, but they could accept credit cards, and they could allow, if you had subscribed to the service, you could even use your cell phone to pay. So that's called pay by phone. And we did that in about 8,000 spaces out of a total of about 29,000. So one of the things we're extremely proud of is this was not just a proof of concept where we took, let's say, 100 spaces. We took the biggest part of the city and the busiest spaces, and we're very proud of what we did. I probably won't go into details since you can get it on the web of how we adjusted prices, but we just tried to get things to what we called our magic goal. And if there was too much parking there, we raised prices till we got them down. But also, if there wasn't enough parking there, we lowered prices so people started parking there just because they discovered it's cheaper. And our goal was to magic or the golden mean. We did vary by time of day and by block. We didn't want to create confusion where the rate would change at any minute. You never knew what it was. So we tried to present consistently to our public that the rates would stay the same for about 6 weeks, at least on the block that you were used to parking on. We did those demand responsive rate adjustments, and by about rate 8, 9, 10, we began to see significant results of what we were doing. Again, the technical capabilities and how to do that are on the web. I am a techie and I could go off forever on that, but I will spare you that. But let's get to what did we discover over the many years of this pilot. We discovered that the average parking rate citywide actually went down a small amount by about 4%. And we also included in this garage parking through a different methodology, but we did include them as part of the on-off street parking as part of the parking demand inventory. We found that garage rates actually went down by 12%. We found that parking availability improved by 31%, meaning if you were going in those places, you had a better shot at getting a parking space within a couple of blocks from where you were looking. We also found, and this was at least to me an unexpected result, was that if you made it easier for people to pay, which meant pay by phone and credit card, they'd be more honest. There was a 23% less what we call non-compliance. Compliance means you got out of your car and you paid. Non-compliance, you didn't. We found a 23% drop in that, which resulted in a financial gain, which was a good thing for us. Also, we found that greenhouse gas emissions were decreased by 30%, and that the vehicle miles traveled also decreased by 30%. So one of the things that we are proud to say is that success is possible. In this particular effort, I like to define it in terms of many things about big data, about Internet of Things. We're now in the space of talking about it and maybe doing some pilots, and I call that broad, but perhaps kind of shallow. SF Park was defined fairly narrowly with some very good metrics, but it went deep, meaning all the way from the actual sensing devices through the operational control systems into the service-oriented architecture or the internet, the connection of things, into databases, into data warehousing, into business intelligence, and then all the way to what I call the presentation layer, which means if you're an analyst wanting an Excel, you can get the data. If you are an iPhone app developer, you can get the data. There's a JSON application feed available. If you're an agency within the Bay Area that wants the data, you can get it. There's an XML feed. So we were very, very, very proud to say that we kind of built a solution very all the way through complete. And what we found was there's so much of an argument between top down or bottom up. We really believe that start narrow, go all the way, and that the real direction to talk about is laterally through the organization. One of the things that we were learning, I think probably my time is up, and do I need to throw it over?
No, keep going.
Okay, let me go into really quickly some of the takeaways, and then we can talk more as Ralph begins to ask me some questions here. Communication networks were a bottleneck, and that they create silos in and of themselves. Project funding, many times grant-based, creates silos in and of themselves. Those are the things that have to be looked at beforehand, before you even talk about technology or you talk about what your metrics are. Because the siloization, if you will, of agencies, of intra-agency projects or business units, and even vendors make the kind of broad-based, cooperative, collaborative environment we're talking about very, very difficult. And that data is the key to everything.
Well spoken. We'll come back to you for a couple of questions. But first, we'd like to introduce our other speaker. Rick Limberg works for a company called SQL Stream, and they specialize in the area of big data Internet of Things type of topics. But one of their great claims to fame is the ability to do real-time traffic analytics, traffic management. And to speak about that, I give you Rick Lindbergh. Rick,
Well, hello. Thanks, Ralph.
span our camera.
There we go. Certainly, everything that Jamie was discussing is pertinent to the world that we live in building smart cities. What we're involved in is the combination of different technologies, streaming and using our stream processor together with groups like Oracle and the big databases and predictive capabilities in order to set the foundation for a smart city that can then be expanded rationally in a way that makes sense. We're in a brave new world. It's something we liken to the Wild West. We've sort of had the Wild West out here in the old days with the gold rush and the Barbary Coast, and certainly the same sort of thing with the birth of Silicon Valley and what we went through decades ago. And I'm seeing the same thing again today. It's really an exciting time where the old players, the core group that have been participating in this sort of massively complicated technology are still playing and doing what we do best, setting up a level playing field for new methodologies to come in and form agile ways to get done what Jamie was actually referring to, the idea of putting it all together in a way that gets things done fast and sets the stage to fulfill the promise of technology for a smart city, which is to make people's lives truly easier, faster, better, in ways that are intuitive, so that the technology isn't the driving force, it's the needs of society that are the driving force for a smart city. And what I'm getting at is what we just came from, very exciting times. Just came back from Australia, and they're running a substantial, I love this term, hackathon, the idea that governments are now serving as the sponsors and the deep thinking organizations that fund what is called a hackathon. I think if we took a poll 5 years ago and asked, would government be the innovative thinkers that would be stimulating this kind of process, I don't know that we would have necessarily seen this coming, but it's the truth of what we're going after today. I like to think ahead that the ponderous methodologies we've used in the past and still are in use today, the RFP, the RFI, this process where it takes hundreds of pages for what I like to refer to as the core players, typically to fill out forms. How are we going to build an app? How are we going to deploy something? Throw a few million, maybe 3-4 million at it. 2-3 years later, you end up with one interesting deployment, may or may not be integrated with the rest of the world. That challenge that Jamie referred to is one of the key difficulties in getting a smart city put together. This new hackathon methodology, it's in its infancy, and I'm sure it'll grow and change and evolve as time goes on, but it's working. And for those of you who don't live in hackfests every weekend like some of us are starting to do now, this is exciting stuff. The idea that instead of just filling out forms and looking at something being deployed in a year, that you bring in talent, that government will sponsor an event that could be a couple of days, could be a couple of months, where agile development groups, university stars, postgraduate experts, the old line industry pros, along with independent developers, come together and compete with the idea that instead of having a single application that, as Jamie referred to, would end up being siloed, and I think this is one of the biggest risks we all face, is that as governments develop their smart cities, there's a lot of this going on, a lot of concern about sharing that data openly with other agencies and with other teams who are trying, in many cases, to accomplish the same thing. You bring together these hackathon-type events where then you've got 100 agile development teams, maybe between 30 and 50 teams, 100, 150 people, competing over a short period of time with a level playing field, with a stream processor, with a database, with all the stored data, with a predictive component, all fully integrated, creating a level playing field for them to participate. And then what comes out of it? Dozens of different parallel applications, all with a simple central theme for this event that can then be chosen. First of all, winners that will be deployed, and then the users of these applications end up being the final arbiter of what makes sense, what gets deployed and used. A true smart city doesn't have rich or poor. It's going to be a creation that's always going to evolve, that's going to benefit everyone that participates. Every citizen has to draw benefit from it. This methodology, this agile methodology we're seeing today, sponsored by governments, and I truly believe this will extend to the private sector in ways that we're just beginning to see how it's going to happen. But with the idea that certainly anyone who's involved with control systems can see that having a competition where multiple fully integrated solutions are created and deployed together can set the foundation for the growth of not just smart city, but getting ahead of what's coming. We have to be able to integrate this into smart states. I love the term city-state that came up earlier. In many ways, that's what we're looking at, is the independent cities who are creating these kinds of deployments, having a necessity to combine their data silos together to create a smart state, smart nation, and eventually a smart world that has integrated solutions that we know, even today, most of what we see will be a dinosaur in a decade or two. We know we're going to be bombarded with sensors.
Rick, let me interrupt you there for a second.
Sure.
I'd like for you to address the solution that you've developed for Sydney, Australia, and the province of New South Wales.
Sure. Well, I've actually been at SQL Stream for 7 years, and we've done, I think, 60-odd projects out there with the government's agencies of Australia alone. And it's followed this path where initially we capture sensor data from, I'm going to get stuck between data and data between Australia and the US, from myriad sources, being able to combine data from the traffic lights, from moving GPS in bus systems and in freight vehicles, fleet vehicles that are monitored by the government, from loop detectors, any kind of real-time feed, join these streams and deploy individual and combined sets of solutions that will enable this sort of consolidation of solution sets as they're created. And through that, we've been able to develop a real-time traffic system that becomes a joy for the analysts within government and externally who are able to see what does the solution contain and what does it enable, and then being able to offshoot that. And the great thing about transportation is all different agencies have some form of transportation hub that they have to deal with. And so transportation, though you mentioned it being one of the, maybe the 6th largest area of the sensor world you're dealing with currently at Oracle, is actually one of the shared areas that almost every industry and every agency has at least some component in that ends up being the foundation for the combination of data silos and the creation of a smart city.
I think in the world of traffic management, every second counts. The sooner you can get to work, the more productive you are, the more productive the region is. It's really a quotient or a part of the formula, at least, for what is a smart city, smart mobility, and the economic development of a region. Jamie, I have a question for you before we run out of time. Where will SF Park go? It seems like it's expandable. And one of the things I like about it is that you have a complete picture of all your parking assets. And that kind of an inventory is a model for other government agencies as well. So can you address both of those things?
I think that some potential futures involve looking at other things as we looked at a parking space is a piece of asphalt, right? We considered that our granularity of an asset. And in there, we could put a parking meter, we could put sensors, we could put many, many things. We're now taking that same concept to overall enterprise asset management, which is a very important thing within the transit world, and is a project I have now transitioned to. Some of the lessons we've learned through the parking we're taking here. I think other future possibilities would be sensing devices in traffic signals. There are certain initiatives called traffic signal prioritization, but allowing those traffic signals to be much more linked in with actual business intelligence that allows them to change the length they're on or off, they're green or they're red, knowing where buses are and other things they're interested in, allowing them through or slowing them down to deal with what's called bunching and gapping along a bus line. And also to even communicate with police departments as if there's an Occupy whatever movement going on that has blocked off a garage or 3 streets or a freeway entrance or exit. Some of the futures, integration with law enforcement, public safety, fire, all those things that are needed to control such an event like that. Because the police would be involved, transit would be involved, garages, streets, city organizers, planners. I can't think of one vertical that probably wouldn't be involved. Even the Utilities Commission, because they were probably going to tear up a street or go inside and do something with infrastructure. So that's kind of one of the futures I see.
That's very, it's a point well taken. The asset management factors in transportation are very interesting. You have a roadway, but you have portions of the roadway that engineers look at, and then you have attributes within those portions. So it's a parent-child, grandchild way of looking at assets. Rick, I'd like to go back to one thing that you said about where you're getting this data, and you're getting it from the internal government. The GPS signals from waste management vehicles, you said, and from police cars. All of those things are sensors in a way, but also the sensors in the roadway themselves. Could you talk about that one more time?
That's right. There's really no limit to how sensor technology can be combined. In fact, I keep going back to what Jamie's examples are because they're very good examples. When you're looking at combining loop detectors with the traffic lights, with the in-vehicle technology that's coming, to create a truly sensitive and growing, breathing kind of infrastructure, it leads to endless questions about why are we not doing this better? And that's sort of the phase of growth we're in as far as a smart city right now. Why are ambulances having to stop at red lights? Why are heavy vehicles needing to stop at any lights during off-peak hours when there's no cross traffic?
Such as around the seaport, maybe.
Exactly. You have to burn a liter of fuel every time you stop and start. It's these kinds of efficiencies that are just the natural developments from this kind of combination of real-time data from multiple sources. There's really no end to how you can manage the pinch points in the system, the bunches of vehicles that as they go through periods of technology, of congestion, to be able to alter congestion itself using all of the different sensors that are out there. We're just at the beginning of this. It's going to just continue to grow.
Ralph, it's Gordon.
Well,
here.
Gordon, we're
Ralph,
at the end of our segment.
Just Ralph to say, it's Gordon here. We're going to be in the afternoon talking on the stage here in Detroit with some of the open data advocates, some of the open data activists who were involved, for instance, in the blight study here in Detroit to try and track and identify every vacant or occupied lot in the city. I want to maybe ask, the final question to the two guests that you have with you, which is a simple, I guess, thumbs up or thumbs down about whether or not governments, local governments, are doing the kind of job they should be doing now in pushing or accelerating in the transition to a world of open data. We've heard, for instance, on the tweets that are coming in while you're talking, we've heard from a lot of folks who say, a lot of cities just don't get it. that they just don't get the fact that the data belongs to the citizens, that it's paid for by their taxes, and that the silos are, in one sense, designed to protect the data from everybody else except the data hogs. And I'm just wondering if the two guests can give us, their sense in really 30 seconds, because we're up against lunch now.
Sure.
Are we closer than we thought we would be now, or are we maybe faster than we think we're getting there?
Jamie, as part of the San Francisco Metropolitan Transportation Authority, I would like you to answer that first.
Sure. I think the quick 15 seconds is, yes, we're getting closer, but as we get closer, we find out that it's more difficult than we thought. Yeah. Because of the lack of standards, the lack of, in many places, citywide champions, but also a little nod and a pinch to the vendor. You've got to really understand a city's pain points and where their budgeting is. I mean, you have to go in for the high value, high pain points and start there, because that's what people will understand. That's what people will allow their governments to fund. So it is definitely get the data out there, but you got to attach it to pain.
Well spoken. Rick, you have seen a lot of cities in your time. I know we were talking about Johannesburg and
Dubai.
Riyadh and Dubai and other cities around the world. How do they approach it? Going off the U.S. shores, what are the other cities of the world doing?
The data that's out there is being integrated. It's a process. There are certainly some data silos that are more flawed than others, so communication is critical when it comes to this kind of open data standard that I do believe is coming. I think it's inevitable. The sharing of data, not just from massive amounts of sensors, but within government agencies themselves, is an absolute requirement in order to break through these thresholds and create what I was discussing, the concept of agile development that works. So it's a change. It's something we all have to get used to. Security is a high concern for all of these groups, so it will play itself out over time. But again, I believe that's inevitable, that we will find solutions for this. And through this agile development methodology, we'll be deploying solutions at probably 20 times the rate that we're used to. Therefore, as creative human beings, we're going to find paths to solve these challenges as we go.
And Rick, just to tell you, we had a hackathon here with really talented people, and we saw the three products that were considered the best of the best from that. You may decide that your company wants to buy all three of them, so check in when we post the details of the hackathon that you missed. Thank you, Rick, for getting the last word. Thank you, Jamie, for being with us from SFMTA, and especially Ralph, a round of applause for our moderator. Thanks so much. We'll see you guys soon.
Thank you very much, Gordon.
Thank you very much.